Alright, now I'm looking at the connection maintained between two end nodes in a network. This is known as the session layer, and in particular, the session layer is responsible for the opening, closing, and managing of these sessions between two end users. That includes authentication, or the checking of the identity of the person at the other end, or whichever end, and the authorization, or providing of access control to the remote system's resources. So authentication, most of you will know this from one or two factor authentication. Um, Things like Steam, Google, many other things use two-factor authentication. When you boil it down to it, authentication is actually a really useful thing because multi-factor is checking via multiple sources or multiple pathways the identity of the user. If you break down authentication into the types, you've basically got three general categories. Secret knowledge factors such as pins, passwords, etc. Ownership factors such as a wristband, ID card, security token, implant, or cell phone, and inheritance factor, i.e. Something that is unique to your individual, such as a fingerprint or retina pattern or DNA sequence. Next up, we have access control and authorization. So an access control, or an access control list, is a list of resources that you're allowed to access within a system. And this could include anything from files, computer programs, all sorts of weird functionality. And the permission to access those resources is known as authorization. And authorization is basically a set of rules to provide access, and who's allowed and who's not allowed. There's, down the bottom, I've listed two forms of authentication, Open Authent and Kerberos, and look them up for yourselves. I think I've provided a link in the PowerPoints in the comment section, so yeah, if you need to. Okay, so while we're talking about access control lists, I want to step sideways into the file permissions in Linux-based systems. So basically, there are three levels of authorized entities that can gain access to a file or a folder. And then we have three levels of access provided to them. Now, the first level of first authorized is an individual, the owner of the file. The second is the group that has access to it, and this can include the user that created it, but also can include multiple other users. And the two don't necessarily need to be related. And then finally, there's the base permission that everybody else gets access to, including external entities to the system. So you don't actually need to be, for example, with an Apache web server. Everybody from the internet's coming across, and they're all external entities, so they get access to read particular files, but they may not have permission to write or execute particular files. Execute's a different matter entirely, because with Apache you might have programs that get executed, but you may not have read or write permission of those files. And there's particular cases in each one with the Apache system. Next up, we have the level of access provided. So firstly, you have the binary value of 1 assigned to the execute permissions, the binary value of 2 for the write permissions, and finally read is 4. And this basically forms what's an octet, or a 3-bit digit binary number with a value from 0 to 7. 0 being no permission to do anything, and 7 being permission to do whatever you like. So that's kind of a simple breakdown of it, and when we go through and explore this stuff in detail, then that'll be great. You'll get a better understanding of it. Next up is the kind of things that can occur at this level, although DDoS attacks are more larger scale. But basically, the goal of a denial of service attack is to cause the target machine to become flooded so that it stops. It's unable to deal with the requests, will crash, or will not be able to handle legitimate requests. Now, because that was all coming from one source, commonly also known as, in some cases, as the ping of death, as one example of it, techniques were quickly developed. Basically, there's a number of ways. Black holing, so the ping, the firing of the message will go into a dead end thing and not even get processed and be ignored, or rerouting it to another thing where it can be appropriately ignored as well. So then the distributed denial of service attack kind of evolved, which has multiple servers basically firing off messages at a target. Given the rise of the Internet of Things, this, of course, is a big problem. So, yeah. And that covers all I want to talk about for this one. So, we're done.